customer said the minivan sometimes shifted harshly at lower speeds, and sometimes the speedometer needle moved slightly at idle. A few preliminary checks revealed normal fluid level and condition, and no fault codes. A road test failed to duplicate the condition. However, the technician knew that a component common to both symptoms was the output speed sensor, so he started checking its wiring and connections. They were okay. The output speed sensor had to be the problem, so he replaced it. But when the minivan showed up 2 weeks later with the same complaint, it became obvious the speed sensor probably wasn't the trouble. So, what next? Try another speed sensor? Replace the TCM? Welcome to MasterTech. The 41TE and 42LE have racked up a lot of trouble-free miles in Chrysler vehicles. And most of the time, a basic knowledge of transmission operation and diagnostics will enable you to correct transmission trouble. But sometimes, troubleshooting a symptom on these transmissions can be a real challenge. In this MasterTech, we're first going to review some of the basic checks and steps used in troubleshooting, with an emphasis on some items that can help you to diagnose the trouble early on. Then we'll talk about some of the limitations you'll need to be aware of when using the diagnostic trouble codes or a limp-in condition as a guide. Following that, we'll turn our attention to some symptoms that are not caused by the transmission, even though they may be reported as transmission symptoms. Finally, we'll look at some late-breaking service information that has to do with a shudder during torque converter operation and what you can do to correct it. Oh, and along the way, we'll be revisiting our apparent speed sensor failure to look at another possible cause of the symptom. You know by now that it's essential to obtain a thorough description of the condition affecting the transmission. The March 1993 MasterTech contains a form you might want to use with the customer when describing the condition. Paying close attention to the details now and during the road test can save you time later on. Take, for example, delayed engagement during a garage shift. Does it occur during shifts to both drive and reverse, or only during shifts to reverse, or shifts to drive? If the delay occurs to both drive and reverse, the front pump and torque converter are possible causes. In the valve body, another possible cause is a sticking torque converter control valve. If the delay occurs only during shifts to reverse, the number one check ball in the valve body is an item you'll need to investigate. If the delay occurs only during shifts to drive, then the most likely cause is a malfunctioning underdrive inner lip seal. The seal may also cause diagnostic trouble codes 51, 57, and 36 to set, and may cause a shudder when the vehicle accelerates from a stop. Of course, there are other causes of delayed engagement, and we'll look at a few later on. Another basic check is fluid level and condition. As you know, low fluid can cause a number of symptoms, including the delayed engagement we just mentioned. Fluid condition can be used to get an idea of what shape the clutches are in. But keep in mind that burnt or discolored fluid does not by itself mean the transmission needs to be overhauled or replaced. In fact, later on we'll discuss a condition that results in burnt or discolored fluid that clutch overhaul will not remedy. Of course, it's also important to always retrieve diagnostic trouble codes, but never use only the code as the basis of a repair. The codes are designed to be used with the information in the diagnostic procedures manuals. We'll discuss trouble codes and some of their limitations in detail in the next segment. Getting back to the basics, one thing you'll notice in the diagnostic procedures manuals is the emphasis on inspecting wiring and connections. This type of inspection needs to be done whether you're working with the manuals or not. The fact is that poor connections and misrouted wiring are the most common causes of electrical problems. What sorts of things should you be looking for? On connectors, check for terminal pushouts. You can check for spread terminals using a gauge made from a connector kit. The January 1992 MasterTech contains information about checking connectors, as well as other valuable electrical system troubleshooting information. On older vehicles in particular, check for corrosion. It doesn't take much to interrupt a signal that already operates at a relatively low voltage. Use the diagnostic procedures manuals as a guide to connector locations and terminal identification. Depending on the transmission, there are only 5 to 7 connectors, and checking them at the beginning can help you track down possible electrical concerns early on. In addition to connections, it's also important to check out the routing and condition of wiring, especially on older vehicles. A misrouted wire can come in contact with moving parts, resulting in a break or chafing. For further information about making repairs to 41TE wiring, be sure to refer to TSB 81690. This TSB also describes how to check connectors and lists some intermittent fault codes that can be caused by poor connections or damaged wiring. Another basic step is to make sure the actual shift lever position corresponds to the position the TCM is reading. Run a shift lever status test and adjust the linkage if necessary. We mentioned earlier that attention to detail is important when obtaining a description of the condition and during road testing. But what sort of details are we talking about? For one thing, pay particular attention to garage shifts and shift points. Are garage shifts delayed? Are upshifts or downshifts delayed or early? You'll also need to note shift quality. Are upshifts or downshifts harsh? Using a scan tool during the road test can give you a better understanding of what's going on in the transmission. The monitor displays are particularly helpful. The RPM monitor includes engine RPM, input RPM, output RPM, TPS degrees, and gear range. We'll look at this monitor's use in diagnosing a particular concern later on. The CVI monitor can tell you whether a particular clutch may be worn or damaged. If preliminary tests indicate low line pressure or a malfunctioning clutch element, you'll need to perform hydraulic pressure testing to narrow down the cause. The applicable service manual contains the pressure test procedure. Be sure to follow the steps carefully to obtain the most information from the tests. Next, we're going to look at using diagnostic trouble codes and limp-in diagnosis. But first, let's check your knowledge with a review question. A minivan exhibits delayed engagement during garage shifts into both drive and reverse. Which of the following is the least likely cause? A, low fluid level. B, front pump. Or C, number 1 check ball in the valve body. The answer is C, the number 1 check ball in the valve body. A stuck check ball would be more likely to indicate delayed engagement only in shifts to reverse. Diagnostic trouble codes retrieved with the DRB3 are a great aid to diagnosis, as long as you're aware of the proper use and the limitations. We already mentioned proper use. The codes are designed to be used with the information in the diagnostic procedures manuals. And as for the limitations, in general, it's wise to keep in mind that the code name does not necessarily indicate the cause of a condition, or that a condition even exists. This is particularly true of codes 21, 22, and 24. Diagnostic trouble code 21, OD pressure switch, can be set inadvertently on 1989 to 1993 vehicles. This can occur if the shift lever is moved toward neutral while the transmission is in 3rd or 4th gear. The transmission will go into limp-in, and the code will set even though the OD pressure switch is okay. Diagnostic trouble code 22, 2-4 pressure switch, can set because of a frozen transmission range switch during cold weather operation. Besides the trouble code, the frozen switch may result in delayed engagement during garage shifts and limp-in. You can use the shift lever status test and pressure testing to confirm that the switch is the trouble and not the 2-4 pressure switch. The frozen transmission range switch can also cause diagnostic trouble code 24, low reverse pressure switch. Another cause is inability to achieve pump prime because of any number of conditions. The inability to achieve pump prime will probably cause delayed engagement into drive and reverse, and may be due to such conditions as low oil level, a poorly sealing filter, or high pump side clearance. Occasionally, you may encounter an intermittent limp-in condition that is not accompanied by a trouble code. When this occurs, the first thing to check is the direct battery feed to the TCM. Pay particular attention to the circuit between the ETAX fuse and pin 56 of the TCM connector. Also check the circuit between the fuse and the battery feed terminal of the control relay. The circuits between the relay and pins 15, 16, and 17 of the TCM also need to be checked. Diagnostic trouble code 12 may accompany the intermittent open in the battery feed. But don't read too much into a code 12 that was set before you received the vehicle. It may merely indicate that someone disconnected and reconnected the battery. Diagnostic trouble code 41 may also accompany some intermittent opens, but this code is likely to appear in the case of an open in the power ground circuit. Be sure to use the checks in the Diagnostic Procedures Manual to isolate the cause. A general rule to keep in mind with the examples we've looked at is that you must consider the trouble code as part of an overall picture, which includes the conditions under which it occurs and the symptoms it produces. Let's look at one more example of the importance of symptoms. Diagnostic trouble code 38, torque converter clutch control out of range, is designed to set if the TCM notices excessive slippage during partial engagement. On 1993 and 1994 Chrysler vehicles, when code 38 is accompanied by vehicle shudder in this speed range, the cause is usually a worn pump bushing or a failed torque converter clutch disc. Technical Service Bulletin 180594 contains more information about diagnosing and repairing this condition, so be sure to refer to it. We'll discuss another cause of the shudder just described later in the program. Before we move on to the next segment, try answering this review question. A vehicle with a 41 TE is being driven in Detroit during the winter. It occasionally has delayed garage shifts and sets a code 22, 2-4 pressure switch. Of the following, which is the most likely cause? A. Worn pump bushing. B. Interruption of power to the TCM. Or C. Frozen transmission range switch. The answer is C. Frozen transmission range switch. The other two causes may be associated with codes 38 and 12. So far, we've looked at some symptoms and their possible causes in the transmissions or in their electronic controls. But in some cases, what may appear to be transmission symptoms have an outside cause. For example, take the minivan at the beginning of the program. You'll recall that replacing an output speed sensor failed to correct what were apparently speed sensor-related symptoms. What was the actual cause of the symptoms? False speed sensor signals induced by the ignition cables closest to the TCM wiring. That's right, the spark plug wires are creating a false input to the TCM. Technical Service Bulletin 8794, Revision B, contains a procedure for diagnosing and repairing this condition. Let's take a few minutes to look at some of the details. To diagnose the condition, you can use the DRB3 scan tool. Select the RPM display under Monitors that we mentioned earlier. With the parking and service brakes applied and the minivan in gear, slowly vary the engine speed from idle to 1800 RPM. Do not perform this test for more than 10 seconds at a time. If the output speed sensor RPM does not remain at 0, you'll need to obtain the required parts and perform the repair procedure. To perform the repair, first, remove and discard the tie strap holding the wiring harness to the right engine mount. And remove the wiring clip from the wiring harness and spark plug cable separator bracket. On 1993 models, you may need to remove a tie strap instead of the clip. Next, remove the wiring clip from the dipstick, but do not remove the clip from the wiring harness. At this point, you're ready to wrap the wiring harness with the aluminum tape specified in the TSB. Overlap the tape 1/4 width and wrap the harness from the oil dipstick tube to within 4 inches of the right engine mount clip. Next, cover the aluminum tape with the black tape specified in the TSB. Once again, overlapping the tape 1/4 width. Triple wrap the harness in the area of the AC compressor high pressure relief valve. Once the harness is wrapped, you're ready to secure it. Secure the lower end of the harness by reinstalling the clip on the dipstick. Secure the upper end of the wiring harness to the right engine mount with the tie strap specified by the TSB. Route the strap through the wiring clip and through the outboard horizontal hole in the engine mount bracket. Next, secure the middle of the harness by installing the clip strap specified by the TSB at the separator bracket. Plug the clip strap into the bracket. On some vehicles, you'll need to use a tie strap at this location instead. After making sure the ignition cables are positioned as far away from the wiring harness as possible, verify the repair with the RPM monitor. Various engine conditions can also cause what appear to be transmission symptoms. For example, on vehicles with a 41TE or 42LE, loss of fuel pressure can manifest itself as delayed or erratic shifts. The feeling of delayed upshifts results from the increased throttle angle. Technical Service Bulletin 14-10-94 details a fuel pump replacement procedure aimed at correcting this condition on minivans. Remember when we talked about vehicle shudder during partial converter clutch engagement? On 1993 and 1994 LH vehicles with a 3.5-liter engine, the shudder may actually be an engine buck or intermittent miss. One possible cause of the miss is oil in the spark plug tubes. Technical Service Bulletin 18-12-94 contains procedures for diagnosing and repairing this condition. As you probably know, the TCM uses a signal from the throttle position sensor in determining shift points. So if the TPS isn't doing its job, neither can the TCM. Now you're probably thinking, so what? A TPS malfunction will show up as a diagnostic trouble code, and I'll just use the code and diagnostic procedures manual. The problem is that erratic TPS operation may not set a TPS trouble code. So you'll notice harsh, erratic, or delayed shifts with no idea that the sensor is responsible. Technical Service Bulletin 18-13-94, Revision A, contains procedures for diagnosing and repairing this condition on 1994 minivans and LH vehicles. It involves monitoring TPS voltage while operating the throttle lever and replacing the sensor if voltage stops or changes erratically. The engine and other components can also be the real cause behind noises that are reported as transmission related. A clunk during garage shifts or lift foot up shifts is usually caused by engine mounts, not the transmission. A click on 1993 to 1995 LH vehicles during acceleration or deceleration or even during garage shifts may be caused by the front hub. Technical Service Bulletin 2-1-94 contains a repair procedure for this condition. It involves increasing the torque on the hub retaining nut. Besides clicks and clunks, squeaks and squeals can also be misleading. When squeals or squeaks occur during garage shifts, lift foot up shifts, low-speed coast down, or coast down tip-in, check the seals between the exhaust manifolds and pipes. They may be loose or worn. On all-wheel drive minivans, you may notice a rolling or bumping noise. But before you get too far into transmission diagnosis, keep in mind that the fuel tanks on the all-wheel drive models do not have baffles and are more likely to produce noises. Fill up the tank and road test the minivan to see if this is the cause of the noise. Of course, the fact that all these noises could be caused by other components doesn't mean the transmission can't be responsible for a noise complaint. For example, a buzz or rattle on 1993 and 1994 LH vehicles can indicate the need to replace the chain snubber. The noise occurs in the 10 to 15 mile per hour range and is present when the vehicle is moving straight ahead or making a right turn. Technical Service Bulletin 21-15-94 describes diagnosing and repairing this condition. In the next section, we're going to look at a very recent TSB, aimed at a condition affecting a wide range of Chrysler vehicles. Before we do, however, let's try a review question. A vehicle with a 41 TE exhibits a clunk during garage shifts. What is the first component you need to check? A. Engine mounts. B. Front hub retaining nut. Or C. Exhaust seals. The answer is A. Engine mounts. These are usually responsible for a clunk during garage shifts. In the past two segments of this program, we've mentioned a number of TSBs, and you may have noticed that most of them did not begin with a number 21. In fact, a number of TSBs dealing with what are or may appear to be transmission symptoms are not in group 21. One reason is that another system may be responsible for the symptom or may need to be repaired to correct it. Plus, the condition may be classified under vehicle performance, in which case it will appear in group 18. The point is that you need to be aware of TSBs in groups besides group 21 when troubleshooting the 41 TE or 42 LE. The key is the symptoms described in the TSBs. In this segment, we're going to look at a very recent TSB published in Vehicle Performance, Group 18. TSB 182794 is aimed at all Chrysler vehicles with a 41 TE or 42 LE transmission. In these vehicles, the electronically modulated converter clutch, or EMCC, may cause drivability symptoms in less severe cases or transmission fluid deterioration in more severe instances. This is most likely to occur with prolonged and repeated vehicle operation between 34 and 41 miles per hour, and the deterioration can occur more quickly in high ambient temperatures. The symptoms of the condition depend on how much the transmission fluid has deteriorated. Symptoms in the less severe cases include shudder or engine surge during EMCC operation. The transmission fluid color is normal in these cases. Severe symptoms include a more pronounced shudder during EMCC operation and harsh converter clutch engagement. Shift quality is also poor with harsh upshifts or downshifts, or even delayed engagement in drive and reverse. In these cases, the transmission fluid will probably be discolored. In all cases, one part of the repair is to flash program or replace the TCM. The upgraded software stops prolonged EMCC operation. The upgraded software can also be used to correct a number of other concerns described in the TSB, including some that we've mentioned in this program. In severe cases where fluid has deteriorated and shift quality has suffered, you'll also need to replace the transmission fluid, following the directions in the TSB. We'll discuss these procedures shortly. Now, as far as diagnosis, in the severe cases, deciding that EMCC is responsible is fairly easy. If the symptoms and the fluid deterioration appear in a vehicle with relatively low mileage, you're probably on the right track, especially if CVI volumes are within the normal range and there are no diagnostic trouble codes. In less severe cases, be sure to cover the basic steps mentioned earlier, such as checking for diagnostic trouble codes to eliminate other causes. Based on the severity and extent of the symptoms and the condition of the transmission fluid, the TSB will refer you to one of two repair procedures. Let's look at the repair procedure for vehicles with deteriorated fluid and symptoms which are severe. The first part of the procedure involves flash programming the TCM with upgraded software or replacing the TCM with a revised control module. All TCMs used with 42 LEs can be flashed. To see if other TCMs can be programmed, record the part number using the DRB3 or look at the TCM label and look for the number on the list in the TSB. The minivan we're working on can be programmed. To perform the programming, you'll need the flash programming kit described in the TSB, as well as the MDS and DRB3. The MDS must be operating with release 16 or higher. To hook up the DRB3 and MDS for flash programming, with the ignition off, disconnect the TCM connector. and connect the 60-way connector from the harness and the flash programming kit to the TCM. Next, connect the flash programming adapter to the 60-way connector harness and connect the DRB3 to the adapter using cable CH7025. After connecting the MDS to the DRB3, power up the DRB3 and adapter by connecting the leads to the battery. Then select MDS Diagnostics from the DRB3 main menu. Select the diagnostic menu on the MDS and then press Next Menu. Next, select Controller Programming. Press Next Menu and select Program Controller Part. After pressing Next Menu and following the prompts on the MDS, the screen will display the application, the present controller part number, and updated part number. Pressing Next Menu at this point begins the programming. By the way, on TCMs that are replaced instead of flash programmed, you still need to use the DRB3 to program the TSB number into the TCM before removing it from the vehicle. You can do this using the TSB option under Miscellaneous. Once the controller is reprogrammed or replaced, you'll need to perform the first transmission fluid change. After removing the pan, be sure to loosen the valve body to drain as much fluid as possible. Be sure to use only MOPAR ATF+ Type 7176 when refilling the transmission. Do not use DEXRON 2 or MERCON. These transmission fluids may cause shift quality problems if used in a 41TE or 42LE. Following fluid replacement, start the vehicle and, after placing the selector lever in overdrive, drive the vehicle at least 5 feet. Then place the gear selector in neutral and apply the parking brake. At this point, you need to determine if you need to perform any additional procedures with the DRB3. If a TCM has been flashed, you don't need to perform any. If you replace a TCM on a vehicle with a 41TE, however, you will need to perform both the quick learn and the electronic pinion factor procedures. If you replace a TCM on a vehicle with a 42LE, you'll need to perform only the quick learn procedure. Programming the pinion factor is not possible on these vehicles. After performing any required additional procedures with the DRB3, the next step is easy. Drive the vehicle at least 10 miles. Then, once again, replace the fluid as described earlier. The only thing left to do is to prepare the authorized software update label and place it on the TCM. The procedures used on particular vehicles will vary according to the symptoms, fluid condition, and TCM used. For example, if the symptoms are not severe and the fluid has not deteriorated, it is not necessary to replace the fluid. Now let's check your knowledge of TSB 182794 with a review question. You're going to perform the procedures in TSB 182794 on an LH with brownish-yellow trans fluid and poor shift quality. If you flash program the TCM, which of the following is part of the procedure for this vehicle? A. Resetting the pinion factor. B. Draining and replacing transmission fluid twice. Or C. Transaxle quick learn. The answer is B. Draining and replacing fluid twice. First after flashing the TCM, and again after driving the vehicle. You do not need to perform quick learn, and it is not possible to perform the pinion factor procedure on these vehicles. This concludes our look at 41TE and 42LE advanced diagnostics. As we said at the beginning of this program, these transmissions have proven themselves in millions of miles of operation. And when a 41TE or 42LE comes in for service, many of the cases we've discussed will be the exception, not the rule. But when these exceptional cases do occur, be sure to use the information in this program, in the service and diagnostic manuals, and in the technical service bulletins to find the cause. And we'll see you next month on Master Tech.